Kia ora year 11 and 12. This is a short video going through some of the main things we did in class today because there were 9 of you away. Okay, so we know that this form of a quadratic equation is really useful. And this one gives us the coefficients that we need for the quadratic formula. But we also know that often a good way to solve quadratics is by factorising. Today we're going to look at the link between the two forms and do a couple of simple examples. Right, so pause the video and try these 4 questions. Okay, so first factorise and solve this little quadratic. Well, we should pretty easily get x plus 2 times x plus 3 equals 0. I've got 2 solutions, either x equals -2 or x equals -3. So what are the roots of that equation? Well, the roots are both of those. So the roots are -2 and -3. Now we can think about all of this if we draw our little parabola. That's a really badly drawn one for this. Let me just fix that up a bit. What I'm trying to show is the x-intercepts are at -2 and -3. Should do this properly in GeoGebra, never mind. So we know that that's the y-intercept there. We know that because if I substitute 0 into this form of the equation, out pops 6. And these roots here are at -3 and -2. Okay, so now let's just work out the sum of the roots. I'm going to give the roots names. You're going to see these often from now on. We're going to call one of them alpha and one of them beta. So when we see the Greek letters, we're talking about the roots. When we see A, B, and C, we're talking about the expanded out form. So the sum of the roots, we've got alpha plus beta is -2 plus -3, which is -5. Now what's the product of the roots? Well, it's alpha times beta, -2 times -3, which equals 6. Now let's take a look at that initial equation. What did we have? Well, we've got A equals 1, B equals 5, and C equals 6. So it looks like for this example anyway, we've got alpha times beta equals C, and alpha plus beta is equal to -B. But that was for a very easy example with an x squared term. We're going to take a look now at a slightly harder one, which has a 2x squared at the start. Okay, pause the video and try and do the same 4 questions for this equation. Right, now you might use grouping to do that, but you can probably do it by inspection. Okay, so when we factorise this equation, here's what we're going to get. I'm trying to keep the video short, so I'm not going to go through grouping again. So I've got 2x times x, and I need to have a plus and a minus. So I'm going to end up with -7 here and +3 here. Now, if that's not feeling easy by this point in the topic, you need to go into your Walker book and go over how to solve those types of quadratics. So that's the factorising. So my solutions are either 2x plus 3 equals 0, x is equal to -3 over 2, or x equals 7. So they are my 2 solutions, and the roots are those 2 values. So we'll call the first one alpha and the second one beta. So alpha plus beta is equal to -3 halves plus 7, which equals -3 halves plus 14 halves, and that equals 11 over 2. Now, I really don't like the format with all the equal signs. You know, I'd rather that you were lining them up down there, but I'm running out of space. So take a look at our initial equation, what did we have for A, B and C? Well, A is 2, B is negative 11 and C is negative 21. So we're looking for a link here that we can work with. But first we're going to do the product of the roots. So alpha times beta is equal to negative 3 over 2 times 7. And that equals negative 21 over 2. So for this example, it looks like we've got the following result. Alpha plus beta is equal to negative b divided by a. Right, there's the negative b, negative 11, and there's the 2, which is a. The product of the roots, well, it looks like we've got, for this example, alpha times beta is equal to c over a. Right, so one more slide. So if we've got a quadratic equation like this, and we find the roots, then we have the sum of the roots is equal to negative b over a, and the product of the roots is equal to c over a. Now, you're probably wondering what all the fuss is, and I get that, but these results turn out to be really useful in solving harder algebra problems. So we're going to do some of those in class in the next lesson, but the next thing I want to do is a video doing the proof of those results. So that's coming up next.